this is Mahathi with Global cli-MATES for the third video in our Introductory Earth Sciences course. Now today, we're not really going to delve into a specific concept in earth science. Rather, we're going to learn about the various scales found and studied in earth science in order to better orient ourselves for content to come. So today, we'll be talking about scales of time and size. And let's just start right off with the scales of time in earth science. So in our day-to-day life, we're familiar with increments of time like minutes, days, weeks, months, and years. Some of us, due to other classes, have become more familiar with centuries and millennia, studying patterns of people over the course of human history. Even still, though, it can be hard to imagine what 1,000 years really is like when most people don't even live for a tenth of a millennium. While, several thousand years might seem really long, in earth science, this is nothing. The Earth is 4.6 billion years old, and throughout its billion years of history, there have been events and processes that have been occurring for millions and millions of years. So these 1,000 years mean nothing to the history of Earth as a whole. So when thinking about scales of time in earth science, it's important to recognize that some processes on Earth have happened and have occurred and continue to occur for several million years. One such example is the processes of mountain building. You may know the Himalayas as one of the tallest ranges of mountains on the Earth. But did you know they started forming over 50 million years ago? It took over 50 million years for the mountains to become as tall as they are, and the process is continuing on for who knows how many more million years. But, these super long increments of time aren't the only increments of time that are studied in Earth's history. Some events that happen on Earth occur in a fraction of a second, such as lightning strikes, or perhaps the trigger of a landslide. Now, this might be a little easier to imagine because maybe some of you have been in a thunderstorm and have seen that lightning strike go away as quickly as it came. But still, it's a little bit hard to think about fractions of a second when we usually deal in a whole number of seconds and usually several minutes. Now, scales of time aren't the only scales in earth science that have two extremes that people just aren't too familiar with. In fact, scales of size also differ greatly in the study of earth science. So going back to, examples of things we're familiar with regard to size, well, some of the largest things we see on Earth are probably mountains. Mountains and then maybe larger countries, and I guess for some people continents, right? But continents is still kind of pushing it, because do you really comprehend how big the continent you're living on is right now? Probably not. On the other side, we can see some of the smallest things we experience are probably grains of rice or sand. In earth science, we study objects that are even smaller than this and even larger. If we think to the most fundamental unit of matter, the fundamental unit that builds up every object, every rock, every tree we see, this object is really a particle, and it's known as an atom. Now, it's hard to describe how small an atom really is, but to put it in maybe a way that might make sense, atoms can't be seen with some of the most advanced microscopes we have today. They're even smaller than what you would imagine to be small bacteria and small viruses. In fact, atoms make up those viruses. And so they're even smaller. And if we start off with the atom, we can kind of construct our own scale with maybe objects that might be more familiar to us and extend all the way out to those huge objects we study in earth science. For example, we start off with this atom. this atom can make up minerals, which then make up rocks that make up mountains. And now we start pushing it as we create continents with these mountains and land. But those continents ultimately contribute to the entire planet. But planet Earth is just one planet in our solar system, which is just a part of our galaxy, the Milky Way. And that's not all, because oftentimes there are various galaxy clusters and groups. And of course, there are more and more objects that continue to get bigger. But you can see here that very quickly, objects studied in earth science get really big. And so, just a recap, we've seen today that scales of time and size in earth science are much different than the scales we're used to in daily life. And this includes even scales of temperatures, where maybe we're used to, a range around 70 degrees Fahrenheit, 25 degrees Celsius. Things get much hotter and much cooler when we go out to space, and even some places on Earth itself. So the main point to take away from today's video is that as we're going forward in earth science, keep an open mind. A lot of the scales and a lot of values on these scales we're looking at are pretty abstract to us because they're just values that we're not familiar with. But with an open mind, you can slowly start to better comprehend, what it means for a process to occur over millions of years and what it means for an object to be several million degrees Celsius. I hope today's video was helpful, and if you enjoyed it, please don't forget to subscribe, like, and comment down below for any questions or suggestions you have for future content. Thank you all for watching. Bye!